Have you ever wondered how we figured out that giant sheets of ice once covered much of our planet? It's a detective story that unfolded over centuries, piece by piece. Today, we're going to dive into the incredible tale of how humanity discovered the ice age. It all started with some very puzzling clues left behind in nature. Imagine you're a scientist in the 18th or early 19th century, hiking through the rolling hills of Europe. You come across massive boulders, some as big as a house, just sitting in the middle of a field. These rocks are completely different from the local bedrock. How on earth did they get there? People called them erratics, and for a long time, their origin was a total mystery. Some believed they were hurled there by giants, while others thought they were washed in by a massive, biblical flood. Alongside these mysterious boulders, another strange feature caught the eye of early geologists. Deep pearl scratches carved into solid bedrock, almost like a giant had dragged a massive rake across the land. These scratches, now called striations, were found all over northern Europe and North America. Again, the Great Flood theory was a popular explanation. People imagined that rocks and debris carried by violent floodwaters had scraped the land. It seemed plausible, but it didn't quite explain everything. For instance, why were the scratches so often aligned in the same direction over vast areas? The real breakthrough came when scientists started paying closer attention to something that still exists today. In the Swiss Alps, local people knew that glaciers weren't static. They moved, albeit very slowly. They would advance and retreat, and as they moved, they carried rocks and debris with them. Early naturalists, like Jean-Pierre Perraudin, a simple chamois hunter from the Alps, noticed that the strange boulders and scratches in his valley looked exactly like the work of the local glaciers, just on a much grander scale. He suggested that the glaciers must have once been far larger, extending all the way down the valley. However, his ideas were largely ignored by the scientific community at the time. It took a charismatic and influential scientist to bring the theory to the world's attention. Enter Louis Agassiz. Agassiz was a brilliant Swiss-American biologist and geologist. Initially, he was a firm believer in the flood theory. He even went to the Alps in 1836 to meet with other scientists, hoping to disprove the growing glacier theory. But what he saw there changed his mind completely. He observed how modern glaciers moved, how they picked up rocks, ground them against the bedrock, and deposited them in long ridges called moraines. When they melted, the evidence was undeniable. The erratics, the striations, the polished rock surfaces, it all pointed to one thing: massive, moving ice. In 1837, Agassiz delivered a groundbreaking speech. He proposed a radical new idea, agredisa arge oraisait in German. He argued that it wasn't just the alpine valleys that were filled with ice, but that vast sheets of ice, kilometers thick, had once covered most of northern Europe, Asia, and North America. He envisioned a world where Scotland was buried under ice like modern Greenland, and ice flowed from the North Pole all the way down to the Mediterranean. As you can imagine, this idea was met with a huge amount of skepticism. It was revolutionary and went against everything the scientific establishment believed. The leading theory, championed by respected geologists like Charles Lyell, was that these features were caused by drift, material dropped by icebergs floating in a huge, ancient ocean that supposedly covered the continents. The debate was fierce. How could ice be powerful enough to move house-sized boulders hundreds of miles? Where would all that water have come from, and where did it go? But Agassiz was persistent. He and his supporters began to meticulously map the evidence. They followed the trails of erratics back to their source mountains. They traced the direction of glacial scratches across entire countries. They identified U-shaped valleys, which have a distinctive flat bottom and steep sides, a classic signature of a valley carved by a glacier, as opposed to the V-shape carved by a river. They found moraine zones, ridges of rock, and dirt hundreds of miles from any existing glacier. One of the most compelling pieces of evidence came from North America. When Agassiz moved to Harvard University in the 1840s, he found the exact same features all over New England. The landscape was a textbook example of glaciation. Long Island, for instance, is a massive terminal moraine pile of debris left. At the furthest point, a glacier reached. The Great Lakes were scoured out by the immense weight and power of the ice sheets. As evidence mounted from all corners of the globe, the scientific community slowly began to accept the reality of the Ice Age. Geologists in Scotland, Scandinavia, and North America all confirmed that their landscapes had been sculpted by ice. The theory that had once seemed outrageous became the accepted scientific explanation. But the story doesn't end there. As scientists studied the geological record more closely, they made another astonishing discovery. There wasn't just one ice age, there were many. By studying layers of sediment on the ocean floor and analyzing ice cores drilled from Antarctica and Greenland, they found a cyclical pattern of warming and cooling stretching back millions of years. These cycles, we now know, are largely driven by subtle, periodic changes in Earth's orbit around the Sun, known as Milankovitch cycles. These ice ages had a profound impact on our planet. The sheer weight of the ice sheets depressed the Earth's crust. When the ice melted, the land slowly rebounded, a process that is still happening today in places like Scandinavia and Canada. The vast amount of water locked up in the ice caused sea levels to drop by hundreds of feet, exposing land bridges, like the one across the Bering Strait, which allowed humans and animals to migrate between continents. The advance and retreat of the ice sheets acted like a giant bulldozer, reshaping entire landscapes, creating lakes, redirecting rivers, and depositing fertile soil. This constant environmental change was also a powerful engine for evolution, forcing plants and animals to adapt, migrate, or face extinction. The megafauna of the Ice Age, woolly mammoths, saber-toothed cats, and giant ground sloths are, perhaps, the most famous examples of life adapted to this cold world. So, from a few mysterious rocks in a field to a grand theory that reshaped our understanding of Earth's history, the discovery of the Ice Age is a perfect example of the scientific process in action. It's a story of observation, curiosity, bold ideas, and the slow, steady accumulation of evidence that ultimately changes the way we see our world. The next time you see a large, out-of-place boulder, or drive through a wide, U-shaped valley, you will know you'll be looking at a message from the past, a powerful reminder of the incredible forces that have shaped our planet. Thanks for watching. If you found this journey back in time fascinating, don't forget to hit the like button, subscribe to the channel, and ring that notification bell so you don't miss our next adventure into the history of science. See you next time.